sometimes there's a lag. It is.
All right, good morning everybody. If you have not met me before, my name is Carrie Hawthorne. I'm the Curator of Education here at the Buttonwood Park Zoo. Happy Friday and welcome to a very different virtual keeper chat than you may be used to. We are in one of our classroom spaces with one of my favorite toys, what we call the Science on a Sphere. And so today, we decided we would do something a little different. Next week is Earth Week with the 50th anniversary of Earth Day coming up on Wednesday. So we thought, what better than a chance to take a tour around why our planet is just so incredibly special today. I do want to give a plug that next week we will also be running a free virtual Zoo Crew program for April vacation. Even if you're not in April vacation camp, it's great science content to add to what you're doing at home. We'll be doing a live Zoom call on Monday and Friday with our campers, and then we'll have daily activities that you guys can follow along with from home. We are also going to be doing a virtual Party for the Planet, which is our big Earth Day celebration, which we normally have here on site. This year, because we can't be together, we're going to be doing that virtually, so definitely check out our website for more information about how you can get some fun activities from our local partners here in the New Bedford area. So like I said, today we are with our Science on a Sphere. This is basically, if you can see me, a giant ping pong ball. So it is a solid ball under here. It's not a hologram. A lot of people think it's a hologram. And then around the room we have these projectors that project in one way. This is a device that was designed by NOAA as a way to kind of create a visualization for people to be able to see really big things like weather patterns and sea currents and all sorts of different things. Today we're going to really go big and we're going to do a tour of our solar system. Now I do want to admit I'm not an astronomer by trade. I am actually much more of a biologist at heart. So I bet there are some friends on our virtual keeper chat today who know more about the solar system than I do. That's awesome. So this is going to be a little bit different. We're also on a tripod, so it's hard for us to see your comments as well as we would like to. But we wanted to make sure we had a nice clear shot of our sphere. So in a minute, I'm going to turn off the sphere. We're going to go ahead and take a tour of the solar system. I'll tell you a little bit. I do want to give you some honesty here. I do have a little cheat sheet, so maybe you'll have some tough questions that I won't be able to answer. We'll see. We'll do our little tour, and if there's time at the end, we will try and take some questions as well. But I am going to go ahead and go over here and turn off the lights so you have a much better view of the sphere. So I'll be right back.
Well, Carrie does that. Just some shout outs to Cindy and Sophia, and good morning.
Hi,
Good morning, Barbara and Diana. Thanks for joining us today.
All right, so hopefully that gives you a much better image. Maybe.
Yeah.
All right, so like I warned you, we're going to talk a little bit about just why our planet is just so special. And probably the most special thing about it, as most of you know, is that it's the only planet that scientists have found to date that can sustain life on it. It's the only place that has this beautiful liquid water. So when we're looking at the sphere, we can see that there is, I'm seeing someone saying that we have a frozen screen. I'm hoping that's not the case.
Can people give us a thumbs up if you're seeing this in live and not frozen? I just saw a bunch of hearts and a thumbs up. So
I'm just going to keep rolling, I guess. So when you're looking at the sphere, you can see lots of cool colors. I should say that all of the images we're going to see today are not paintings or drawings or cartoons. They're actual satellite images taken from space. So we are actually looking at a satellite image of Earth from space, and you can see just how beautiful she is. The blue ocean is our liquid water that sustains life on Earth. The green is our plant matter, our trees and our rainforests and grasslands that we can see from space. The white, we see a lot of clouds up there. And I do want to I should have said it at the beginning, so I'm going to come back over real quick. I'm going to be running the sphere with this iPad here, which has all our data sets on it. I can actually turn it and twist it so we can see. There's also not only white clouds, but there's also white ice and snow on our poles, the North and the South Pole. And so, one of the ways that people describe Earth is they actually call it the Goldilocks planet. And if you've ever heard the story of Goldilocks, you know that she tries to eat the bear's porridge, and some of it's too hot and some of it's too cold, and then one of them is just right. And the Earth is in the same situation. So if it was any closer to the sun in our solar system, it would be too hot for life. The liquid water would evaporate and boil up and go away. If it was any further away, it would be too cold. And so it truly is in just the right place to be protected from harmful solar radiation, but also it's able to stay warm because of our beautiful atmosphere that includes water and carbon, and just I can't say enough how special it is. So we're going to go way out into the galaxy here. We're going to take a look at home. So this is actually the Milky Way. And so our planetary system, our solar system that we call home, is located here in the outer arm of the Milky Way galaxy. Beyond our own solar system, believe it or not, there are more planets in the night sky than there are stars. So scientists have discovered thousands of planetary systems orbiting around stars just like ours in the Milky Way. And more planets are being found every day. Most of the hundreds of billions of stars in our galaxy are thought to each have their own set of planets. And the Milky Way itself is one of about 100 billion galaxies. So if we really think hard about that, just imagine our place in home is just one tiny planet on one solar system that's part of many solar systems on this galaxy, which is part of about 100 billion other galaxies. So that's pretty amazing to think that we have found this amazing rock called Earth where we can sustain life. Pretty amazing. And I really encourage you to go look at that night sky whenever you can. All right, so now we're going to step back a little bit more. And what we're looking at right now is actually our solar system kind of shrunken down to show you the planets by size. So this would be how big the planets are if the sun was the size of our 6-foot globe. So you can see how the sphere is now yellow. This sun is represented by the sphere, and then you can see each of the planets is the planets based on their size comparison, if that makes any sense. You can see just how big Jupiter is compared to everybody else, but also how big it is compared to the sun. So our solar system was formed about 4.5 billion years ago, and it consists of a star, our sun, and everything bound to it by gravity. So our current count of orbiting planets around our star is 8. We have our inner rocky planets, which are Mercury, Venus, Earth, and Mars, which are those 4 tiny ones to the left over there. And then we have the outer planets. We have 2 gas giants, Jupiter and Saturn. And then we have 2 ice giants, Uranus and Neptune, the 2 blue ones on the right. And then beyond Neptune, as a lot of you are going to probably start to say, we do have a newer class of smaller worlds called dwarf planets, including Pluto, which you don't see here because this is just our actual proper solar system. And so you may be asking yourself, what makes a planet a planet? I know that's something that I was curious about. There are 3 requirements that have to happen for you to be called a planet. One is you must orbit a star. In our case, that would be the sun. You must be big enough to have enough gravity to hold yourself in a spherical shape. So you have to be round like our planets are here. And then you have to be big enough that your gravity can clear away any other objects of similar size as you're orbiting around the sun. And in 2006, that is what happened to poor Pluto, that got downgraded to a dwarf planet because it didn't have the 3rd requirement of being big enough to clear away other objects. All right, so now what we're going to do is going to take a walk around our solar system. And like I said, these are all satellite images taken from space. So this is one of the more important parts of our solar system. I bet you can guess. This is the sun. It really is the heart of our solar system. And it is basically a yellow dwarf star or a hot ball of glowing gases. And you can see it having flares right now. Just to tell you how hot those gases are, the sun's core is about 27 million degrees Fahrenheit. That is really hot. And its gravitational force, the size of it, is what holds the solar system together. And it keeps everything from the biggest planets to the smallest particles of debris in its orbit. And the connections that we have and the interactions that the sun and Earth have, both our orbiting around it once a year and our turning once a day, really does drive our seasons, our ocean currents, the weather, and our climate. So we can't stress enough how important our sun is. Our plants need it to grow. All right, so our first planet from the sun is our friend Mercury. Mercury is the smallest planet in our solar system. And it is basically, just to put it in perspective, about the size of maybe a tiny bit bigger than our moon here on Earth. So our moon is about the size of Mercury. It's pretty small. And despite it being the closest to the sun, it is actually not the hottest planet, but it is the fastest planet. So it spins around the sun every 88 Earth days. So its year is basically 88 Earth days, which is pretty cool. And to put that in perspective, you all probably know that the Earth's orbit is 365 days or a year. The daytime temperatures on Mercury can get up to 800 degrees Fahrenheit. And there are no moons for Mercury. It has no moons. It is too close to the sun to hold on to its own moons, basically. All right, let's head next door to Venus. So Venus is very similar to Earth in structure and size, but if you look at it, it is very different. You don't see the beautiful life that we have on Earth here on Venus. Venus slowly spins in the opposite direction from most planets, so that's an interesting thing about Venus. It does have a thick atmosphere that traps heat like a runaway greenhouse effect. So it makes it the hottest planet on our solar system at about 880 degrees. The surface temperatures on Venus can actually be hot enough to melt lead, which is pretty crazy. It is covered in a thick cloud of cover, but you can see here we've kind of pulled that away, and you can, when you pull that away, you can see that there are lots of volcanoes on Venus. And actually, Venus also has no moons. And from what I understand, that's a complete mystery to scientists why Venus would not have any moons of its own. All right, the third planet from the sun, you all should know by now, is Earth. This is our home right here. It's the only place we know of so far that's inhabited by living beings. It is the fifth largest planet in our solar system, and it is the only planet with liquid water on the surface. It's slightly larger than Venus, and it is the biggest of the 4 rocky planets, and we have one moon, and I'm going to go ahead and show you a satellite image of our moon too. So this is our moon. So we only have one of these, which you would know, because if you've ever looked out at the night sky, you'll only see the one, which I think is one of the coolest things. As we get into some of the other outer planets, they have lots of moons, and I just can't imagine the idea of standing on the planet and looking out and seeing so many moons in the sky. I think that's really cool. All right, we're gonna leave Earth and our moon and head over to Mars. So here is Mars. Mars is a dusty, cold desert world with a very thin atmosphere. It does have seasons. It has polar ice caps, weather, canyons, and extinct volcanoes. And I'm just going to turn it so you can see it has polar caps similar to us. So on the top and bottom, there are small little caps of ice, which is pretty cool. Let me reset it back. It is one of the most explored bodies in our solar system and the only planet that we've sent rovers to roam around on the surface. So those robotic explorers have found lots of cool evidence that Mars was really much wetter and warmer with a thicker atmosphere billions of years ago. And Mars has 2 moons. So we're moving up in our moons here. All right, next to Mars, we have the largest planet in our solar system. That's going to be Jupiter, one of my favorites. So Jupiter is twice as massive as all the other planets put together. So if you can imagine that, it's bigger than all the other ones put together. And I think for me, this is helpful to think about it. If we looked at Jupiter, we could put 1,000 Earths inside of it. So that's just how big it is. And those stripes and swirls that you see on Jupiter are actually cold, windy clouds of ammonia and water. And those things are floating on top of an atmosphere of hydrogen and helium. And the winds on Jupiter can range up to 335 miles per hour. Pretty crazy. Now you see that big red dot towards the middle of Jupiter there? That's what's called the Great Red Spot, and that has been around for hundreds of years. Since we've been observing Jupiter with telescopes, we've been able to see that giant red spot in the same spot, and that is basically a giant storm there. And that giant storm you could fit 3 Earths inside of, so it's huge. And like I said, it's raged on for hundreds, as long as we've been observing it. And Jupiter has more than 69 moons. And I'm just going to show you one of Jupiter's moons, because I just think it's pretty cool. Hopefully you do too. Now, our next planet is going to look a little different to you because we don't have the ability to show you its rings. This is going to be Saturn. And Saturn is one of our giant gas planets. It is the second largest planet in our solar system, and it does have thousands of beautiful ringlets, making it one of the more unique planets in our solar system. It is not the only planet that has rings, though, but they are definitely the most intricate. And those rings are made up of chunks of ice and rock. And like its fellow gas giant Jupiter, it is a massive ball made mostly of hydrogen and helium. And Saturn has 62 moons. All right, we'll head next to one of our giant ice planets, Uranus. So this is, most of it is a hot, dense fluid of icy materials, which is water, methane, and ammonia. And that's all above a small rocky core. And it has an atmosphere made mostly of hydrogen and helium with a small amount of methane mixed in. And like Venus, it rotates east to west, but I think its most unique feature is that it actually rotates on its side, which none of the other planets do, at almost 90 degrees. And there's a theory that maybe a large Earth-shaped object might have knocked it onto its side many moons ago. And Uranus has 27 moons and 13 known rings. The inner rings are narrow and dark, and the outer rings are brightly colored. All right, next to that we have our friend Neptune. And Neptune is a dark, cold planet that is whipped with supersonic winds. It is an ice giant and the 8th and most distant planet in our solar system, and more than 30 times as far from the sun as Earth, so it is way out there. It is the only planet in our solar system not visible to the naked eye at any point in time in the year, and it was the first planet to be predicted using mathematics before we could actually find it and see it with technology. And it has 14 moons. And then just because everyone loves Pluto, I will include Pluto, our dwarf planet. And there's a lot of back and forth. Is it a planet? Is it not a planet? I was on NASA's website last night and they were calling it a dwarf planet, so I'm going to go with that. But like as I said, I am not an astronomer by trade, so you may prove me wrong, and that's okay. You will notice that Pluto's picture is really blurry in parts, and that's because Pluto is so far away from us that we can't get our technology to the point where we can get clear images of the whole thing yet. But every year we get a little bit better. In 2006, I believe it was, or I might get that wrong, but they did a trip out there and were able to get much better images than we've ever gotten before. And so, like I said, Pluto is a dwarf planet. It is much smaller than even our moon. It's about 1,400 miles wide. So to put that in perspective, that would be, if we sat Pluto on Earth, it would be about half of the United States. And like I said, it was downgraded to a dwarf planet in 2006. And I think the most interesting thing that they've learned about this planet as they've been able, or dwarf planet as they've been able to study it, is that it does, when you're out there, it does have blue skies, spinning moons, mountains as high as the Rockies, and it snows there, but when it snows, it's red, which I just think is so cool. Pluto's surface is far too cold to sustain life as we know it. Temperatures range from -378 to -396 degrees Fahrenheit, which is crazy cold. And it has 5 moons of its own. So that was a trip around our solar system. I hope you loved seeing all of our beautiful planets and learning a little bit, hopefully, about them, or maybe you know more than me, and that's okay too. I don't know, Shara, if any questions came through that I would be able to answer, but I'm happy to, or if you have something you'd really like to see me put up on the sphere, I'm happy to do that too. We have lots of cool things to show you. We'll probably come back and do different topics with the sphere, but we can stick around for a minute if anyone has anything.
A lot of people commenting how cool the sphere looks, and it definitely does. And so there was a question about Pluto being a normal planet.
Yeah, like I said, there's a lot of debate about it, and I go to the source. I find NASA to have the best information, in my opinion, and that's where I went to for my information. But it could be, it's ever changing, and the amount of exploration that happens with the solar system is incredible, and I'm just really impressed by the science that goes on and the exploration, and it really allows us to step outside of ourselves and think of ourselves in a much bigger way. So that's what I love about it.
Rachel was saying that Mars was out bright last night.
Yeah, if you have, put Mars back out. If you don't have it on your phone, there are some really great apps, like night sky apps, where you can point your iPhone or your smartphone up into the sky, and it will tell you what you're seeing, which is a favorite activity that me and my daughter do a lot, because you'll see stuff that's out there and you'll question, am I looking at a star? Am I looking at a planet? So
do we have any pictures taken by the Hubble? Was the question.
Let me see what I got. So we have exploration, missions.
And then there was another question about the storm of Jupiter. Why does that never go away?
What was the question?
Why does the storm, the red eye, the great red spot?
That's a great question. I don't even want to guess that, because I don't want to imagine. It has something to do with the way Jupiter rotates. It does rotate almost straight, so it's not tilted on its axis at all. It is pretty slow moving, so it moves at a rate of about, its length in years is about 12 Earth years. So you can imagine it goes around the sun once every 12 years, as opposed to our 1 year. And then its day is about 10 hours. So it might have something to do with the way of its spin and its rotation. But I don't want to make anything up beyond that. So I would definitely recommend looking into it, or maybe someone else will know.
Kaylee is asking, can you show Venus? She hopped on late.
Sure. And I'm not seeing any Hubble. I apologize.
And then Sydney wanted to know if we could see the galaxy again.
Sure. Let me put Venus back up for you. Yeah, Venus is the brightest planet in our solar system. And this is actually an image of a radar of Venus. So they basically used a radar to map the surface of it. So basically they've taken the clouds off so that you can see it better. And I might be able to find a different view of Venus with the cloud cover, but maybe not. Oh, here we go. So this is what Venus actually looks like to the naked eye. We'll go back and forth to a bunch of different images, but that first one, that's what it would look like if we were looking at it, but then they took a radar to make that image so that you can see what the surface might look like under those clouds. And then the Milky Way is right here, our galaxy.
Which is amazing.
Yeah. If you can find yourself in a spot without a lot of light pollution, it's really amazing to be able to see our Milky Way.
You are welcome, Jalen.
So if you are just joining us, we did just take a tour of our complete solar system, and I recommend you go back and watch the whole thing if you missed any of our planets. I hope that you enjoyed a kind of different virtual keeper chat than we normally be back with the sphere. We love being able to show this to our visitors in class. And we hope you'll join us to celebrate Earth Week.